Hey everyone. Today we're going to build, or we're going to delve a little further into the queue. This time we're going to take it for kind of a spin using what it is kind of designed for in a lot of different companies and things like that. In class, I usually talk about Disney and grocery stores. And essentially, if you ever notice when you go to a grocery store, of course, Walmart or Kroger or any grocery store, wherever you happen to be, usually they have a rule in place. You know, when a line at a teller gets too long or whatever, or a server, they may open up a second line, depending on the business. Now, that being the case, they know what that is, well, based on experience, but you can also build simulations to kind of run that and see how things would work. Like if I have this many people, how long would they be waiting in line? How long would it take my server to do this? How many people would it take to get overwhelmed? Because there is a point in time where people would be, you know, waiting in line and get tired of it and walk out. People walk out, you lose business. So they want to minimize the amount of time in lines. Now, in amusement parks and things like that, you're kind of it's kind of a little bit different as you're trapped there. You can't just walk off and leave because you're tired of waiting for a ride. Uh, I know we've got a few amusement parks here that I've been to where you go there and annoyingly enough, there's a sign that says, "Hey, 40 minutes until you reach the ride," and you just have to stand there looking at all the people in front of you that will ride before you, and that's infuriating. Disney does it infinitely better. I mean, you still see people in front of you, typically, but not all of them. You always like shuffled off through rooms and hallways, and there's always stuff going on and TVs and little whatchamadoos on the wall to keep you entertained. So you don't notice the wait as much. You don't notice all the people in front of you. You don't even know how far you have to go a lot of the time. Well, maybe I'm almost at the front. Maybe I'm 30 minutes away. Whereas, like other theme parks, will explicitly tell you, like, haha, you've got an hour to go if you're standing right here. Uh, which is just terrible, but they can't build it quite as fancy. So what we're going to build today is a little line simulation program. Uh, we'll have one server that serves the line, and people are going to get in that line. And I am taking a whole lot of stuff here at just guessing and throwing it in there. I'm not pulling it from any hard data or anything. It's just so we can see how this type of program would run, not necessarily actually use it, because I don't have all the hard data that you would use for this. So close out my extra things. So there's a lot of guesswork and me just kind of randomly putting things in there, just so you know. Now, this right here, I need a random number generator, so that's important. And I call this program serve me. And it's got several classes to it. If you're watching this video, you can pause, copy down as we go. And I tend to put comments at the end of every, function, at the end of every class. That way I know where that end is supposed to be and where I need to tab over. It just makes it easier to read. So, I have a class called customer. And customer, maybe I should just pull out the old paint here. All right, so we've got a customer, right? That's our first class, right there. We'll just make a little box, I think. Shoom, like that. Perfect. All right, so we're gonna have a customer. We're gonna have a server. Make a little box for that as well. If I can move my mouse, there we go. All right, and then of course we have the queue. Right? Now the queue we've made, customer is relatively new. And what a customer is going to be is a customer is going to be just a person that gets in line. In our previous project, we did widgets. This is going to be customer. Customer is a little bit more detailed, as you can see. We got a different set of functions here. So the first thing is the constructor. And what we've got here is I've just decided to set the customer's happiness. They're going to have a happiness and they're going to have a wait time. Now, happiness, I picked 100 being, like, oh, they come in perfectly happy. And that is not always the case. In real life, sometimes people come in just angry as you can be. There's really nothing you can do to make them happy. I've stood in line where a person in front of me was so agitated, he was next in line, but it wasn't going fast enough, so he just walked right out. So, and I've had people who are perfectly fine sitting back there for an hour and a half playing on their phone while they wait. Depends on the person, but I'm just going to assume everybody's happy. So there's a lot of assumptions made in this project. Now we have a couple of functions. Add adds happiness to the customer. So whenever a customer leaves the line, leaves the queue, I'm just going to assume everybody's pretty happy about that. So we're going to randomly bump it up 1 or 2. Sub, every time they have to wait a turn, they get a little less happy. And again, I'm kind of randomly picking numbers here. We subtract from their happiness, we add to their happiness. I can add to their wait times while they're waiting in line. We can get their happiness, which I'm not actually sure if I utilize that or not, but if I need to get that value, I can do this. I could just say directly .happiness, but it's better programming to have a get method. You can also get the wait time, same thing. Now this function here checks to see if they're happy, and my definition of happy is they're 50 points or higher than 50 points. So I assume anything less than that, they're unhappy. Again, it's kind of an arbitrary choice, but this hopefully kind of illustrates how someone would kind of, better data build something kind of similar and kind of utilize it. All right, so that's my customer. I have a queue, and the queue is, of course, the line itself. This queue is a queue of customers. So we've got a customer, and the queue is a queue of customers here. The server is the one that's going to be in charge of the queue itself. So this is kind of the hierarchy here. The server holds the queue and all the little statistics we're going to keep track of. The queue is a queue of customers, like this. So that's kind of the order. Now, I'll zoom in. My queue is a bit different. If you remember in previous assignments, I figured out that, hey, I don't necessarily have to utilize the front and the back option if I just use this as a list, which it is. I have a front and a back already kind of built in, and I can remove the front, unlike an array where I can't. So I do have a couple of lines of code here that really aren't very useful for this. Like, I'm not actually going to be using these per se, but they're just kind of remnants from the previous version. So just a heads up. And also, it doesn't hurt to know how that previous version works, because sometimes you can't use a list for stuff like this. But all right, in queue, of course, puts a customer in the line here. So I just, if it's full, I say if it's full. If it is empty, then I put them in. And actually, I said put item here. We should adjust that a little bit to say putting customer into the front of the line. There we go. And then I append, which just puts it in the list, increase the size. Else, well, you can't go in the front, and it's not full, so I put them in the back of a line. Now, before I utilize this line here to figure out where the back was, I don't need that with the current version, so I'm just going to comment that out. And of course, we add them to the end of the list. Append just puts it at the end. And then we have increase the size. Voila. So we scroll our way down, and we get to DQ, which is take out of our queue. We have a size. I do if else, if the size is full, or I'm sorry, if the size is empty, don't do anything, we can't take it out. Otherwise, it's not empty. So my value is the first item in the list. I just pop that over there. This is exactly the same queue as before. I can delete a very specific location, which I do, 0, the very top. And again, I don't necessarily have to have those because I'm not really using them. So I'll kind of leave that as it is. And of course, I decrease the size because I've removed it. And I can return it so I can save it if I need to do anything with it. Now, the few new options we have here, we have increase. An increase, if you look right here, is, if the size is 0, there's nothing to increase. All this is going to do is go through and increase the happiness of everyone in line. So if someone leaves the line, everyone in line is happy. They left. So it will call add for each customer. You see add here. And it will increase by a random 1 or 2. If I scroll up, add gets called. And every customer goes up by 1 or 2. And again, those are arbitrary number choices. So, and that's increase. Decrease does the exact opposite. It decreases. It runs the subtract version, which subtracts 1 to 2. And everything else is kind of the same. And again, I don't really need the front, so I can kind of comment that out, really. So it's not really necessary for this version of it. Again, for a normal array version, it would be. So we scroll on down, and we have our third class, which I believe I mentioned was server. So a server is going to hold the queue line for my server. It's going to figure out the wait time of the first person. Don't particularly care about the other people per se. It's just worried about the first person. Now, technically, we do have a wait time on my customer. And if I wanted to make this a random time and not have the server do that, I can have the customer do that. But I'm using the server in this version. So I have it basically so I can kind of do either or. Total number of happy customers. This is going to be a statistic at the end. It's going to go through, and when a customer comes out, we're going to check to see if they're happy or not, or unhappy. We're going to check how many we served. We're going to check how many people entered the line. So this is just some statistics we're going to keep track of. And this is something people would do to figure out effectively when they should open up another register or something. How they should deal with their lines if it gets a certain length. Having all those statistics can tell you that. You can make the line longer, make the server more efficient, and see how that affects the line. You can add multiple servers and see how that affects everything as well. Now, add customers to the line. That's what this does. It just adds customers. So when this is called, whatever number I pass to it, it's going to add that many numbers of customers to the line. So if the queue size is 0, well then I just get a random number, self.serveTime, and I make a customer. Actually, am I utilizing this? Let me see here. Oh yeah, I'm getting a serve time. Okay, this is the serve time for that first customer, is what that is. I'm setting this server's serve time, that they're using that to figure out how long the next person served. So I'm getting a random serve time. I set it for 1 to 3. Again, that's arbitrary. And the 1 to 3 is essentially, I guess you can consider kind of a minute or one iteration of the loop that I'm going to be running. Every iteration of the loop that we're going to be doing later, customers can come in, they'll get in the line, and my server will serve whoever's in the line first, and then the next customer. So I create a customer, and I enqueue them. And I got this set as a loop, so if I get 4 customers, then 4 of them would pop in. 1 of them, then 1 of them would pop in. 0, well then this wouldn't run at all, and no customers come in. Check is something that happens at the end of each line. Now I have some try except here because I was having some errors I actually don't think they're necessary anymore, but just in case, I'll leave them in there. I don't actually believe I need them at the moment. There were several places in my server where I was crashing, and I was playing around with it to figure out, and most of it amounted to, well, me not paying close enough attention to the 200 and something lines that I wrote. So, anyway, what this does, check. It's going to check to see if it's basically time to serve somebody. And if it is, then we do some decreasing of the serve times. Well, let's start at the top here. So if we have somebody in line and it's not time for them to be served yet, we decrease the serve time from the server by 1. Now I could, like I said, put this on the customer instead, but it depends on how I want to write it. In this particular version, I wrote it so the server keeps track. And the server only cares about the person that's in front of them. If I did it the other way around, it would be the customer that would keep track, and I would subtract it from them. So I print off how long they wait, and then I run the decrease function, which makes everybody unhappy because we're waiting. Now, if somebody is in line and it's time to serve them because they've hit the 0 mark, then I get rid of them. I pump them out of the queue, put them in this C location. I increase the stat, how many people we served, and I increase happiness to everybody. And again, I do this try except here because I was getting some errors before. I think that's pretty much taken care of now. So I probably don't actually need those, but I'm going to leave them there for now anyway. Probably should still be able to run without it. Well, anyway, C is who came out. I'm checking to see if they're happy or unhappy. That's what this line does. And as you can see, I was getting an attribute error before. So if I don't want those, I can just comment them out. But then I'll have to space these back like this. So I think I don't need those anymore. So I'll just leave that commented out for the moment. And I guess I don't need that either. So I was playing with all these. All right, so if queue size is greater than 0, then I get a new serve time. So coming here in this line, I'm serving somebody. And it comes all the way down to this indif here. You see, that's why I put these little comments so I can clearly see what's supposed to be inside of the other thing. So I serve somebody, I get the next customer serve time. That's what this does. Now, stats. At the end of my program, I'll display this, and it'll display the number served and happy, unhappy customers, whoever's currently in line, and also like how many people walked in. And if I wanted to add some extra, if somebody gets angry enough, maybe I'd have them walk out. I could keep track of that. With the list structure, that would be a little easier to do actually compared to an array. Now, my main. I have a server, and I say that the line has 200 slots. It doesn't really matter. I can make it 50 slots, or 100 even. And range, I'm going to print, or make this run, let's say 200 turns. So you could just pretend like that's minutes. So maybe 180 minutes, 3 hours. I get a random number for customers coming in. Again, it's random, arbitrarily chosen. 0 and 2, and if it's 0, well, I print no customers. If it's 1, then I print 1 customer, and then I add it. If it's 2, I print 2 customers, and then I add it. And just so you know, this right here could be easily shortened with a little loop and some variables. That's it. So if I needed to do like several customers coming in, I probably wouldn't expand it this much. I would just do a simple for loop, 1 if statement, and then I'd be done. And then we run check. So this is going to go 180 turns. At the end, I'm going to check to see if somebody needs to come out and do all the check stuff we saw at the server. And it's going to loop again. Once it finishes its 180, I print the stats. And this is all on my little main here, and I run that. So let's see if we crash or not. I'll run it. Now it's printing each turn, or each rotation, and there's going to be 180 of them. So essentially, I just have to wait. Oh no, I've clicked on it and I shouldn't have. Okay, there it goes. All right, so we got turn 0 to 179. I should probably change that 1 to 180, but let's see. We have 100 customers in line. It looks like the queue was full for quite a while, actually. Queue is full, queue is full. 100 is nowhere near enough for the number of people that are coming in compared to coming out. We had 39 customers happy and 20 were unhappy. And I guarantee you most of the unhappy were probably near the end. The way this line pretty much works, I had 200 people walk in actually, is, the line's just going to keep getting bigger and bigger. One server is not enough for this. And if I ran this thing, I could figure that out pretty quickly. So I could make a second server if I needed to, server 1, server 2, and I could put people in that line instead. I'd have to code that, of course, but effectively I can make this so I can have a whole list of servers even if I wanted to. And then I could just set it, adjust it, see how it works with 2, 3 servers, see where it needs to go to where I need to open up another server. And the statistics are used, like I said, grocery stores, amusement parks, kind of figure out when they need to do whatever it is they need to do with the line. But this right here is your Serve Me project here. And again, I'm taking a lot of stuff just like with a grain of salt here, just throwing in the numbers for the most part. There's nothing really hard, factual about any of this. Happiness is not exactly something you can really rate. It's just something I'm doing for this one project so we can kind of get a little bit more in the way of statistics. And I've left a couple of things here, I'm not actually using the wait time on my customer, but I could, depending on how I want to code this. I decided to lean to having the server do it instead, but I left that value there. But there you go. That is serving customers in a nice little line simulation.